Hi, and welcome to this video on processing large XML without using an XML port. Hey, I'm Eric, and in a few videos we kind of touched upon high performance, big processing, big data sets, and lots of you have asked for this. So I thought let's actually try to do something with XML, with a big XML, and without using an XML port. So here goes. Here is my Visual Studio Code, typically the first thing I open. And as you can see, I got a XML file here with some, well, actually, this is some very, very clever created fake data made by Steve Endo. If you haven't checked his channel, go check it out. Awesome stuff. But here I got 420,000 lines of XML. So let's process it. And just to not to bore you guys too much, I have already created a table with kind of the same fields that we have in the XML. Also created a view, so a page, so we can see the data. So let's start by creating a, well, we'll create an import function in this video, not just start with an import function. So we need to add some code. So let's create a code unit. And the reason I said let's do this without using a XML port is that XML ports are great. Don't get me wrong on that. I love XML ports, but XML ports are great when it's straightforward, when your data matches your tables. And right now in my example here, my data do match tables. So this video would be done in a couple of minutes if we were just to create an XML port. But what's the fun in that? So with Business Central, compared to Nav, where the story was way more complicated, with Business Central we have native data types for handling XML, and let's use that instead. So let's create a procedure here to import our XML. And the first thing is that we need to get the data of file into Business Central. So we'll do that with a if upload into stream, and we try to remember what upload XML. We have a dialog. Let's see if we can get that tooltip somewhere else. We have a dialog. No, we can't. Let's see. There. Haha, don't move a muscle. I got you now, Protovision. From folder doesn't matter, from filter doesn't matter. File name, we need a file name, and we need an in stream. So if upload succeeds, then so let's create those variables. We got them. We need a in stream, and we need a file name. So far, so good. So upload into stream will prompt the user to upload, and you select a file. And if the upload succeeds, then upload into stream returns true. And then we have the XML in the stream. Unfortunately, we don't have XML readers, so we can like kind of stream process it. So we have to load the entire XML into what is known as a XML document, and we could call that, let's call it XML doc, right? The reason I said that in nav this used to be complicated is that we would end up having to use the XML DOM, OLE, automation controller, and all that stuff, or .NET. But now you can see that there's a bunch of data types now for handling XML. So we can just do XML document. And this is actually quite simple. So we can do another if, and then so another change between how AL used to be or CAL used to be and AL is that AL has static functions on the type, sort of like in what you have in .NET in C#. So I can actually do if and then do XML document. So now this is still the type. This is not my variable. This is the type dot, and there are functions here. There's a create function and a read from. So we're going to use read from, and in our case we're going to read from our in stream, and then we have to read into the document we just create the variable for. So in case this goes well, then we can do stuff. If this does not go well, we can error out and say cannot parse XML, not ML, though XML. So now we have our 10 megabyte XML document sitting in the XML doc variable. So the first thing we can do now is the 10-second primer on XML is that it's a SGML data version of a document. So there's always a root element. In this case, it's called XML_data. So there's always a root element. That's just one of them. So what we can do now is use the function called getRoot. And then we need a variable to store the root in, and then we'll just, let's call it root, and we'll use the XML element. So as soon as you work with this, you will discover that sometimes you need XML elements, sometimes you will need XML nodes. And this afternoon I tried to look up what's actually the difference, and one is inherited from the other, but they're kind of the same. And I think what I do is I go with the flow. So in this case, getRoot, as we can see, returns an element. So my root is an element. Then other things that as we progress here, we'll probably need XML nodes, and then I'll just use nodes. If somebody has a great explanation for the difference and when to use what and so on, put it in the comments below, because a short, simple explanation for that would be awesome. Anyway, so we'll get our root. Again, this one also returns a Boolean. So if there is no root in the XML file, meaning that I guess the only way that the parse could be valid and then there's no root is that the XML is only the header, but I don't care right now. So we will let it fail terribly if there's no root. And then so now we have that element, and what's important when we're working with these variable types is that we need to think about the internal structure. So in this case, now we have an element. That element have child elements, and in our case they are all called record. So there's tons of entries all called record. So what we can do now, oops, not there, here, is that we can ask for the child elements, and let's root dot get child elements. And either we can get them all, or we can get the ones that have a specific name. So we could ask for all the ones that's called record, in case there's something else. I don't think there is in this file, but we'll just use this. And what do we get from get child records? We get a XML node list. So let's create a variable called records and let that be an XML node list. Awesome. So now we got a list of all the records in this thing. So now we can do for each, and so this was a node list. So now we know that the thing we probably need is a node, not an element. So for each node in records, do begin. So with that, we're just looping over all the nodes that are in the node list. Very C#ish. And what can we do on a node? We can convert the node to, so kind of node is kind of like the base entity, so we can convert it into an element or a document or text and so on. And we, of course, we can ask what it actually is. But we can't really work with it, what's inside it. So just to make it a bit easier, more readable, let's create a variable, let's call it E, which is an XML element. Then do E equal node as XML element. So what can we do on a element? We can look at the name of it. We can look at what is called the inner text, and that one is important because that's actually the value, so to speak. So it's kind of so when we're looking at something like, in this case, the record, then all of this is kind of the inner thing, which doesn't make any sense from a perspective of this being multiple entities. But if we're looking at something like last name here, then we know that we're at the deepest level. That there are no child elements to last name. So in this case, the inner text is actually just our value. So let's remember that. So for now, we know that we have a record. So the E is kind of our record. So let's actually get our record also. Let's call that data. And what was our table called? It was called XML data. So now I guess we're ready to initialize this one. And let's look at the primary. We can see here that the row ID is the primary key, so we need to fill that out. If you're a subscriber to the channel, you might have seen the video on how to do data validation the right way. If not, I suggest you subscribe, and because tons of good videos and more stuff coming. So now I would like to do data row ID equal, just to make it nice, here, equal what? So now we need to create a helper function for this to be a delightful experience. So let's go down and create a function here. Get text, let's call that. That takes a XML element and a name of a field, and this one will return text. Something like that. I think that makes sense. So if we look at our element now, we can see that as soon as we're looking for child stuff, we get plural, get child elements, get child node. That's because XML is kind of weird that you know, we could add another one with the same thing. And as long as we're in a XML file without any validation and schemas and all that good stuff, that's totally valid. But we know that there's only one. So what we can do, let's go back here, is simply say that let's add a variable field node. That should be an XML node because we saw that. So we can use the for each again here. For each field node in e dot get child elements, and we want so that this one has some overloads. You can see you get them all, or get the one with a specific name, or get if there's a namespace in play, but there's no namespace in this. So we'll just grab it, get all the child elements that has the name we're asking for. And I guess that's kind of it. So as soon as we get one, we know there's only one. So even though we're in a for each, we just want the first of it. So now we can do field node dot as, because this one is a node, so we need to get an XML element dot inner text. So now we have a function. Let's repeat what we have. So get text on an element and a name of a subfield, returns the text, find the field node. So in case, we could do this differently, I guess. We could also kind of do a one-liner, get child elements name, and then that's a get the first one. The get returns, there's no overload to that one, so we can't really do it in one. But the for each will give us the fact that if there aren't any, we're just returning a blank, meaning so the way, if you use the programming in C# or stuff like that, it will tell you that if you have a return value on a function, you need to make sure that all paths of the procedure do return something. In AL, it's not as strict. So in this case, if there aren't any child with that name, there is an implicit exit with a blank string here. I could write it, but it's already there. So that the for each will prevent the if there is an element or not. So now we can go back up here, and we can't, because remember this was actually an integer. So let's create, so now we have a get text. So let's create a one more of these procedure, and do a get integer. And this is the same element and name. I could copy paste, but now we want to return an integer. So we know that we need the field node, needs to be an XML node, and then let's create a variable called value that needs to be an integer. And we'll do the for each field node in e get child elements name do. And now we have the inner text, right? So we need to convert that into a integer. And the proper way of doing is still encapsulate that the function is the evaluate. And so you can see evaluate takes a variable. So in this case, that's a value. Then it takes the string. So that will be field node as XML element dot inner text. And then you can see that also takes a number. Let me see if I can get this out of the way of myself. And here's a magic number, and the number is 9. So the only third parameter you can put on evaluate is the number 9. And as soon as you put a number 9 on this, that means that normally when evaluate is running, then it takes into account what kind of local localization things you have. What is your decimal separator and all that good stuff, how you're formatting dates and yada yada yada. But if you put a 9 here, that means you can still see, sorry. That means that ignore all that and just use the rules of XML. And again, just to make this proper, we'll put in this inside an if, and then we'll exit the value. Perfect. So in this case, since it's an int, there might be a 1000 separator, but let's make a copy of this one, this function, and let's do get date time, because date time is so in AL we have date, we have time, and we have date time. Out in the real world, date and time are kind of just a subset of a date time. So if we do and say this one should return a date time and the value should be a date time, then now we do have a proper conversion for date time. So evaluate will, since value is a date time, it will now do a proper XML date type conversion. So as long as we add the 9, then all the conversion stuff works. Anyway, let's go back up to this one now, and we can say get integer e comma, and then this one's called row ID, and data insert true, and data validate. Wow. Validate company, and then get text e and the field company, and data modified true. I can fill out more. Let's do 2 more. I'll just copy this one, and then I'll do what did we have? We had we have a field called first name and last name, and first name and last name. Let's see, was that it? First name, last name, company. Yeah, we're good. And not date modify, but data modify. So this looks exactly like the pattern in the video on validation, even though we're now actually working with XML. Let's wire that into our page. So here we need to call import, that's a code unit, XML. I've totally forgot how I named it's just called XML data, code unit, XML data, that's it. And import, import dot, and see here's the interesting thing. So now get date time, get int, and get text are shown here because I didn't go down and say, okay, these should probably only be called from within the code unit if we're looking at a. So if we go back here, import dot, now we have import dot import. That's kind of nice. F5, let's see if this compiles or not. Well, it compiled, so far so good. I'm deploying to a BC running on Docker. That's another video, if also last week, I think. So we'll hit import, and we'll choose our, not a SharePoint connector thing. We'll choose something from the YouTube folder. We'll choose our 30,000 thing, and let me actually do the stopwatch here and say I click open, start the time. Let's see how it goes. We're getting close. Time flies. Come on, PC, you can do it. Go, 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 go. And so far, no errors. So far, working on it. I hit the stopwatch and I thought, that's it. But not really. There we go. So 28 seconds. And for importing 30,000 records. So that's pretty nice. And we got first company name, first name, last name. Let's go back and check if, go away with that, go away with the debugger, and go up and let's look at that first guy. Brand Acne for hungriness was number 1. That's it. And let's go down a bit. So number 7 is Ricky Dolly for hydrophytic troubled. Steve, this is too hard for me to read. Anyway, Ricky is number 7, so this works. So that's one way of doing it. The approach here I kind of like, because what we end up with, we have some plumbing code down here, and that's generic plumbing code, and I have code that kind of look like this in a lot of places, because it's kind of just, plumbing. So at some point, stuff like this could probably be submitted to as a pull request to Microsoft to add into the system application app. If you remember one of the JSON, what's one of the web service videos, we kind of did the same thing just for JSON. I think we also did some of this kind of with the US Postal Service app. Anyway, this looks nice. This looks readable, maintainable. What we can do, because the challenge here is that if we look at it from a high performance, I don't know if 28 seconds for upload, parsing, and inserting 30,000 records is fast or slow. I think that's acceptable. But we might think about the fact that we are getting a lot of elements. So we could reduce some of the calls. So another way of doing, I'm just gonna look at the time. We're already at half an hour. So bonus context coming up. If you're doing this, you're in good shape. What you can do, there's 2 other approaches here. instead of this, we could actually use our for each, and then we need to create another node and call that field node. Wow. So we could do field node for each field node in, let's get out of this, in get child elements. And now we're getting all, this time, remember we did get child elements and we just got one. So we had to ask the parser to go down and find it. So instead, now we're getting a list of all of them. And now we can do a, let's create another variable here called, let's call it field, which is an element. So now we could do that field equal field node as XML element. And then multiple things. We could do case field.name and say, okay, when this is company, wow, company, then data.company is equal field.inner text. And if this was row ID, then we had to do an evaluate data.row ID and then field.inner text, 9, and so on. So in this case, we are only getting the child's elements once for each record. So this will probably be way faster. Just we can try it out. Then we actually need to, hang on, do first name data.first name equal field.inner text, and last name. We need to do the same amount of fields, otherwise it's not comparable what we're doing. Last name is equal field.inner text. We also need to do one more thing here. We need to add an action clear. So we need to add an action on the page that deletes our data, otherwise we either have to delete it during the import or it won't work. So we can do delete all. There you go. So let's go back and look at this loop. So we're looping, we're getting, converting, and at the end here we need to do a data.insert. And now you're going to tell me, but Eric, you did a insert and a modifier. Now you're only doing insert. True. Yeah. So it's not completely apples to apples, but let's find out. You're not not all tables can be inserted that way proper. So I'll reset my stopwatch. We'll find our trusty 30K file. I'll click and start the stopwatch. Let's see what happens. Now we're at 5, 6, 7. Boom. That was less than 8 seconds, I think. So there is a price to pay for all the extra operations. So 8 seconds for the same thing. So the interesting thing here is that clearly in the first method, adding more fields will add more lookups of get child elements. This one, I only do one, and it's perhaps a bit harder to read. So we could say that this was okay. So now I'm just gonna do the third one also. So if you're done with this video, I don't blame you. It's long and it's late night here in British Columbia. First one, but let me at least talk about the third one. Second one here. So first one, kind of classic. Second one, we take advantage of the child elements. The third one will not be faster. I think the second one is the fastest. The third one might be less code if you have tons of fields. Third one. So what we can do, and some of you might guess, let's introduce a RecordRef and add a field ref because I'm gonna need that in a second. And I think I need a integer just to do some looping. So what we can do here is do ref.open database XML data, and now we can do for e=1 to ref.field count, do begin, and let field ref equal ref.field index. So I've done a few videos on RecordRef, so go check them out if this is totally new. But basically now I'm getting the field. So what I need to do now is actually to do a case of the field ref type, meaning that, and we need to do an off here, I think, because we need to handle different fields in different ways. So if field type is integer, then we know that field ref dot value should be get integer of e and our field ref dot name. So the name, because what here's the trick for this to make any sense. I should have started with that. Then if, as it is the case with my data, that the names inside the XML is the exact same names as in my table. So I can use the field ref. So saying that, okay, we have a field and that is field.name. So let's get that from E. And we can do field type text and field type, because this is going to be the same code. We're going to do field ref.value equal. So as long, whenever you're working with field ref.value, you need to make sure that you are assigning the right type. Otherwise, everything will blow up. Field refs are very type sensitive. Don't give them the wrong type. They will get mad at you. Field ref.name. And I think that would be enough. Let's compile it for a second. So I'm just gonna remove this insert because now, and since we're doing this in a loop, let's make sure that we close it again. So we'll do ref.init here, and then we're doing ref.insert here, and then we're going to do ref.close. And for this to work, I need to comment this one out. Then the first one is still comment out. And let's see if this works. We'll clear the data. We'll hit import. We'll choose a file. I'll reset the stopwatch. Click OK. And I'm looking down at the Visual Studio logo icon in the bottom row. There, boom. And that took 9 seconds. Oh, yeah, so 9 seconds. And you see the bonus content here is that we got basically all fields filled out. And what we did was, so this is very compact, right? So we covered ints and text and code, and I think that's the only data fields in reality we have in this table. Yeah. So we got the element with all the fields. Then we loop through all the fields so we got the XML with all the fields. Then we open the RecordRef and loop through all the fields in the table and see if there is a field in the XML with the same name as the field we have in the table, and assign the value and then insert. So let me refresh and then I'll let you guys go. Oh man, I typed 5 here, so we need to undo. Wow, that was stupid. Let me copy this and then I go undo. There we go. Oh, that's good enough. So first one, classic, very classic, true validation, everything is ordered, but also of course the slowest because we do the most. Second one, we loop over the entities in the XML and assign that. Third one, we loop over the fields in the table in BC and assign on that. So the second one was fastest, the third one was just the second behind it, and the first one was the slowest, but perhaps the most correct one. Anyway, guys, that turned out to be a way longer video than planned. I'm sorry about that. Hope you enjoyed it. If you did, let me know in the comments below. Subscribe if you haven't subscribed to the channel. That's the best way of supporting what I'm doing here. And until next time, have a wonderful day.